Now my dear students, today we are start the in crash course this chapter organic chemistry, some basic principle and techniques plus hydrocarbon. We are starting this chapter my dear students, and we learn various type of concepts with reactions my dear students, and through these questions, and those questions which are come in previous year examination, NEET examination. Now we take the question number 1. Here this question number 1 is asked in NEET 2019 my dear students. And what is the question? Question is that the number of sigma and pi bonds are in pent 2 for ine is. Here my dear students, if you put the pent means 4 carbon atom, 1, 2, 3, 4 and 5. These are 5 carbon atoms are present, 1, 2, 3, 4, 5. It is called pent. Double bond is present on second carbon atom here. This is second carbon atom. So, in fourth carbon atom, ine is present. Here 1 carbon atom, 1, 2, 3 and fourth. Ine is present in fourth carbon atom. This is fourth carbon atom. Now, my dear students, here he said that how many sigma and pi bonds are present. Here my dear students, what is the concept of this question? You know very well, when carbon single bond is present, this bond is called my dear students sigma bond. When you can get the carbon double bond carbon, then you can get the 1 sigma bond and other bond is a pi bond. My dear students, when you can get the carbon triple bond carbon, then you can get the 1 sigma bond and these are 2 pi bonds. So, my dear students, here this is the concept and we can apply this concept in this question. We can apply this concept in this question. My dear, we can see here 1, here pi bond is present, here 2 pi bonds are present. So, total pi bonds that equal to 3 pi bonds, and you can see these options, only one option you can get 3 pi bonds, other one no pi, 5 pi and 2 pi. So, my dear students, this is a very easy question for you and you can get the answer B, because you can get 3 pi bonds. How many sigma pi bonds? If you see this whole molecule, then we can draw the whole molecule CH3, CH, double bond CH, single bond C, triple bond CH. You can also count the sigma bonds here. You can also draw the structural formula of this CH3, CH, double bond, CH, here C, triple bond CH. Here my dear students, you can count the sigma bond also. This is the 1, 2, 3, 4, 5, 6, 7, 8, this 9 and this is 10. So, my dear students, you can see here sigma bond is 10 is also present. This is a question which is asked in NEET 2019. Now, my dear students, here we can see the question which is asked in 2018. Here my dear students, we can see here question number 2. Which of the following molecules represents the order of hybridization? sp2, sp2, sp, sp. Now my dear students, first of all, you see the concept. Concept is that when carbon single bond carbon is present, these carbons are sp3 hybridized carbon atoms. These carbon atoms are sp3 hybridized carbon atom. When my dear students, number 2, when carbon double bond carbon is present, then it is sp2 and sp2 hybridized carbons are present. When, my dear students, you can see here carbon triple bond carbon is present in the molecules, then this carbon atom is sp and this carbon atom is also sp. Hybridization is present in carbon atoms. My dear students, when this carbon atom is attached in one side triple bond and here other side single bond, but this carbon atom is sp hybridized. So, when triple bond is present in carbon atom, it is a sp hybridization is take place. You can see in these questions and in these options. First of all, sp2 means double bond. Here you can see this carbon atom is sp because triple bond attached. Here this is sp. So, this is not answer. Now, we can take, my dear students, here this is sp2, double bond is attached. Here this is sp2. Okay. Here it is sp because triple bond is present. Here this is sp because triple bond is present. That is why, my dear students, your answer is B. B is your answer, my dear students. And in B option, these hybridizations are present. Now, my dear students, when we see the question third, the total number of pi bonds electrons in the following structure is. Total number of pi bonds electrons in the following structure is. Here, my dear students, 1 pi bond. Here you can see second pi bond, third pi bond and fourth pi bond. You can see concept is this. You can see 4 pi bonds are present. Or in one pi bond, my dear students, 2 electrons are present. In one pi bond, 2 electrons are present. So, 4 pi bonds, 4 multiplied by 2, that equal to 6 pi electrons are present. This is our concept, and your question is 4 multiplied by 2, that is 8. 8 electrons are present. Not 6, it is 8 pi electrons are present. So, answer is D. Now, my dear students, we can go to the question number 4th. Here question number 4th, we can see here same. This question is also want the sp, sp2 and sp3 hybridization in the carbon atom, and here want C2 carbon atom. Here you can see the C2, where is C2? C2 is present here, and in this C2, my dear students, this carbon atom is attached with this 3 carbon atoms, that is 3 double bonds. So, it is called sp hybridization or sp hybridized. Now, when we can see this C3 single bond is present, that is why this carbon atom is sp3. Now, here we can C5. Here C5, my dear students, here you can see this carbon atom is attached with this double bond. So, it is a sp2. Here C6, this C6, here C6, only single bond is present, that is why hybridization is sp3. This is the concept, my dear students. If you know this concept, you can solve all the questions which are asked in your NEET exams very easily. Now, my dear students, C2 sp, here you can see here is sp, sp3 is present here, wrong, sp. C3 sp3, where is present sp3, here sp2, wrong, sp2, wrong. You can go answer D because you have only one chance, only one answer you have. That is why this is correct answer sp3. Now, we can see that this C5 is sp2, yes. Now, we can see the C6 is sp3, yes. So, these are the hybridization of these compounds, my dear students, and it is easily you solve, my dear students, you can solve. Now, we can go to the question number 5th, which is asked in NEET 2008. Here you can see 1, 3, 5. You can find out that this sp hybridization of 1, 2 for sp, here 3, it is sp3, here 5, this is sp2, and this equation of hybridization 1, 3 and 5. Here 1 for sp, you can see here where is sp here in 1 and A and D option sp is present. So B and C option is wrong, you can remove it. Now third carbon atom is sp3, here third carbon atom is, first carbon atom is this sp, so this is answer sp, and third carbon atom is sp3, so you can go the answer D. So you can go the answer is D. Fifth question, answer D. This question is also asked in NEET 2008. Now my dear students, we can see here question number 6. In which of the following compounds there is more than one kind of hybridization for carbon? Means more than one hybridization are present in a carbon. You can see here sp2, 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 sp2. So one type of hybridization is present in this compound. So this is not answer. Here sp and sp. So this is not answer. Here my dear students, all carbon atoms contain sp3 hybridization. So it is the answer. One kind of hybridization is present here. But in which of the following compound there is more than one kind of? Question is that more than one. Here one type of hybridization is present sp3. Here you can get sp only. Here you can get sp2 only, and here you can get, this is sp3. Here this carbon atom is sp2, double bond is attached. Here my dear students, this carbon atom is sp2 and this carbon atom is sp3. So answer is D. Because question is asked more than one kind of hybridization is present. Here in the three options you can get only one type of hybridization, sp2, sp, sp3. This question asked in NEET 1995 examination. Now my dear students, we can see the question number 7. A straight chain hydrocarbon has the molecular formula C8H10 and the hybridization of the carbon atoms from one end of the chain to the others are respectively sp3. First carbon atom is sp3, you can write from one end, the hybridization of the carbon atom from one end of the chain to the other. This is one end to the other. Here this is sp3, here you can see the sp3, then sp2, here you can see the sp3 and sp, here you can see the sp3 and sp2, here you can see the sp3 and sp2. Now my dear students, this sp3 sp2 is present, so this sp3 sp2, this is wrong answer, and three options are. Then sp2, here sp is present, here this carbon atom is sp2, sp3 sp2, here sp2 is present, so this is also correct. Here you can see the sp3, yes, you can see here sp, so this is not answer. Here A and C are not answer. Then you can see here sp2, here sp2, and then 2sp2 sp2 is present, so this is not answer. So answer is only D, and you can find out this question number 7, answer is D. You can find out the hybridization. For carbon this sp3, this carbon sp2, and this carbon make the hybridization sp2 because double bond is present. Here no double bond is present, all are single bond, that's why hybridization sp3. Here hybridization sp2 because double bond is present. Here this carbon atom is attached with this double bond, that's why hybridization sp2. Here my dear students, you can see the triple bond attached with this carbon atom, hybridization sp, and here you can get the sp. So you can see that this arrangement or this order, first sp3, yes, sp2, here you can see, then sp2, then sp3, then sp2, then sp2, then sp and sp. So my dear students, answer is D. And question number 7, you get the answer D. This question is also asked in, my dear students, year 1991. Concept same. I repeat once again this concept. When carbon single bond is present, all single bond is present with carbon, hybridization sp3. When carbon atom attached with double bond, hybridization is sp2. When any carbon atom attached with a single bond or triple bond, then it is the hybridization is sp. So this is the basic concept of my dear students, and you can solve this all questions from this basic concept. Now we can go to the question number 8. Here, which of the following possesses a sp carbon in its structure? This question is also come in 1989 NEET exams. Here my dear students, this CH2 is attached with this double bond, and this carbon atom is also attached with double bond. That is why it is a sp2 hybridization is present. Here you can see the sp2 hybridization double bond is present. Here this carbon atom, my dear students, double bond is present concept. My dear students, when CH2 double bond C, H single bond CH, double bond CH2 are present, here it is the sp2, 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 sp2 hybridations are present in all the carbon atoms of carbon. Now my dear students, when we see this CH2 double bond C and double bond CH2 here, my dear students, this carbon atom contains 4 carbon atoms, means these pi electrons are take part in the triple bond. So my dear students, it is also a sp hybridized carbon atom. So your answer is C. In this carbon atom, it is sp hybridized carbon. This carbon atom is sp hybridized. If you have 3 carbon atoms are present, it is also a sp hybridized carbon atoms. So my dear students, these are called sp hybridized carbon atom. Now my dear students, this is the question number 9. We can see here the Cl-CCl angle in 1,1,2,2 tetrachloroethene and tetrachloromethane respectively will be about. My dear students, here we can make the structure number 1, that is ethene 1,1,2,2 tetrachloroethene. Here you can, this is the double bond which is present between carbon and carbon. Here 1 Cl, 2 Cl, 3 Cl and 4 Cl are present. So this is called 1, 2 carbon atoms. So you can say here 1, 1, 2, 2 tetrachloro. Because here my dear students, 4 chlorine atoms are present, that is why it is called tetrachloroethene. 1, 1, 2, 2 tetrachloroethene. This is the first compound, and here second compound is our this tetrachloromethane CCl4 compound. This CCl4 is called tetrachloromethane. Here my dear students, this is your second compound, tetrachloromethane. Here my dear students, these both compounds, question want what is the angle. It is a very simple question my dear students. You can see here hybridization of the carbon atom. Here my dear students, hybridization of carbon atom here, that is sp2. Here hybridization of carbon atom is sp2. Here hybridization of carbon atom is sp3. Then you can find out angle easily. In sp2, in sp hybridization, angle is my dear students 180 degree when lone pair of electrons are absent. In sp2 hybridization, angle is my dear students 120 degree. If you get the sp3 hybridization, then you can get the angle is 109 degree. 109 degree and 28 minutes or 5 minutes, you can say that. So my dear students, you can see here first compound is your, that is tetrachloroethene, because this compound, in this compound my dear students, double bond is present, so it is a planar and hybridization is sp2. Here this is sp3 hybridization is present, tetrachloromethane. So angle is this one, this show 120 degree and this show 109 degree, 5 minutes or 109 and 28 minutes. So, my dear students, your answer will be A. Why? Because in this compound you can see the hybridization sp2 and in this compound you can see the hybridization sp3. Now, my dear students, when we see the question number 10, an organic compound X molecular formula C6H7O2N has 6 carbon atoms in a ring system. 2 double bonds and a nitro compound as substituent axis. Here, my dear students, C6H7, first of all you can see the O2N. O2N means NO2 is present here. So, you can write here concept. You see this concept. Here functional group is NO2 first of all, because you can see the O2N. O2N means NO2 is the function group. Now, we can see number 2 point. You can get, my dear students, C6H7. What is the C6H7? Here, my dear students, C6H7 means cyclic ring is present, because in cyclic rings, in benzene ring you can see the benzene ring. C6H6 is present in your benzene ring. So, my dear students, when you can see the benzene ring C6H6, but here one hydrogen atom is extra. One hydrogen atom is extra, and this NO2 is also present in this molecule. So, you can say that when you have a C6H8 compound in which one hydrogen atom is replaced and NO2 is placed, then you can get the C6H7 NO2, and this is the molecular formula which is given in your question. My dear students, has a 6 carbon atoms in a ring system. 6 carbon atom is a ring system, and 2 double bonds are present. Here you can see that 2 double bonds are present, and a nitro group as a substituent. NO2 you can place here as a substituent. So, my dear students, what is this compound? It is not aromatic, because here alternate double bond single bond is not present. Here number of pi bonds are 4, while in Huckel groups number of pi bonds that equal to 6 must be there. So, it is not a aromatic. But my students, here this compound is a homocyclic, because all the carbon atom are attached with each other and all the carbon atoms are present in this compound. Only single same atoms are present in the ring, so it is called homocyclic. So, my dear students, this compound is called homocyclic compound, but it is not aromatic. So, you can go the question number 10 A part. Now, my dear students, we can go the question number 11. The IPC name of the compound is, here first of all you can make this is in this way. This is 2 year of this carbon atom, 1 year here and 1 year here. Now, you can trace of this year, and you can say, if you plot the numbering of carbon atom 1, 2, here 3, 4, 5 and 6, then you can form this compound, my dear students, H, C, double bond O, this C, and this C is attached with this CH3 group. Now, this C is attached with this oxygen atom. Now, this CH, double bond CH, and last one is this is CH3. Numbering of 1, 2, 3, 4, 5 and 6. 6 carbon atom chains are present here, and you can see here this is the CO group, this is the CH double bond CH, and this is another CO group. My dear students, numbering is start from this carbon atom. Here you can see on second carbon atom you can get the methyl group. So, methyl group on second carbon atom, here you can check This B is not correct answer because methyl group is present on 5 carbon atom. Here my dear students, you can check the C, methyl present on 2 group, and here methyl present on second. It may be C or may be D. A methyl group is not written, so it is not answer. Now we can see here third carbon atom CO, keto is present, okay. Methyl is present and Hags. Here my dear students, you can give the numbering of double bond. Here double bond is present on 4th carbon atom. Here numbering is present on 4th carbon atom, that is why you can see here 4 in. And CHO group is present on 1st carbon atom, that is why it is called ul. So it is called 3 keto 2 methyl Hags 4 enol, and my dear student, this is the correct answer. Our answer is 11D, 3 keto 2 methyl Hags 4 enol. Now my dear students, we can see the question number 12. The structure of isobutyl group in an organic compound is. Here my dear students, isobutyl group. What is the concept? You write here concept and you see this concept. When single carbon atom chain present in the group, then it is called an butyl group. When single carbon chain is present in the group, it is called an butyl group. When side chain present on this group, then my dear student, it is called 1 and 2nd carbon atom, then it is called isobutyl group. So you can see the in which option this group is present, and you see that this group is present in 1, 2, 3 in C option, because this group is present in C option. So my dear students, it is a correct answer. 12th C is the correct answer, and this question is asked in NEET 2013. Now my dear students, we can see here question number 13. Structure of the compound whose IPC name is 3-ethyl 2-hydroxy 4-methyl Hags 3 in 5-bunic acid. My dear students, this compound is formed in this way. We can write here concept. Here you can see 3-ethyl 2-hydroxy 4-methyl Hags, means 6 carbon atom must be there. 1, 2, 3, 4, 5, 6. 6 carbon atom is present here, my dear students. Number 1. Number 2, ethyl group is present on that 3rd carbon atom. Number 3, OH group is present on 2 carbon atom, and double bond is present on 3 carbon atom. 1, 2, 3, double bond is present, and enoic COH group is present on 1st carbon atom. Now we can here see first 1, 1, 1 and 1. Here that is 2, OH group is present on 2 carbon atom. Here 2 carbon atom, 1, 2 and 3. OH group is present on this 3rd carbon atom, that is why it is not answer. Here you can see OH group is present on 1, 2, 3, 4, not answer. Here answer is C or D. Now we can put the numbering 1, 2, 3, 4, 5 and 6. Here my dear students, this 3-ethyl, here you can get the 4-methyl because 1 carbon atom is present. Here this is a 2 carbon atom is present, that is why it is a 3-ethyl. Here 3 ene, here 5 ine and 1 oic is present, that is why your answer is D. 3-ethyl, 2-hydroxy, 4-methyl, Hags, 3 ene and 5 ine is present. So answer is D, question number 13. Now my dear students, we can see the question number 14. Here in question number 14, which nomenclature is not according to IPSC system. Here you can see that bromo and double bond is present. My dear students, what is the concept? Concept is that preference of the preference is given according to this. First of all, you give the preference of functional groups. Then, my dear students, you can give the preference of substituents. Double bond and triple bonds are also taken as a functional group here, and substituents halogen, NO2 nitro, and this NH2 is taken as a substituents. So, you can give the preference for this functional group, then substituents. Now, my dear students, here this bromo is a substituent, and here this double bond is a functional group. So, here write 1, 2, 3. This is the correct IUPAC naming 3 bromo probe 1 in. But here you can see 1 bromo probe 2 in is given. So, answer is this, A is the answer. Not according to IUPAC system, this answer is given. So, my dear students, you can see here this question is asked in 2012. So, you cannot go to the B, C and D options because you can get the answer A. So, why you can go B, C, D option, but we can see here also. Okay. Here, my dear students, this is a BR, numbering 1, 2, 2 methyl. So, you can give the numbering 1, 2, 3, 4, 5, 6. So, my dear students, you can see for bromo 2 and 4 methyl group is present. So, you can see here for bromo 2,4 dimethyl hexane. Now, we can see here this is the compound 1, 2 and 1, 2, 3. So, you can go to the numbering in this side 1, 2, 3, 4 and 5. You can see here, my dear friend, this is a methyl group present on second carbon atom, phenyl group present on third carbon atom. So, my dear students, it is called 2-methyl 3-phenyl pentane. Now, this is also a correct answer. Here you can see the numbering is given for this COOH group because preference is you can here see COOH group give the preference than CO group 1, 2, 3, 4, 5, 6. Then here you can see this 5-oxo-hexanoic acid. All the naming of these compounds are correct, only one naming it is wrong, and that is A, and this question is asked in 2012 NEET exam, and we give you a concept. Now, my dear students, we can see here question number 15. Here, my dear students, the correct IUPAC name for the compound is, here you can see here 1, 2, 3, 4, 5, 6, here 4, 5, 6, 4, 5, 6. You can go, you can get the only 6 carbon atoms. So, you can go in this side or in this side or in this side. Which side you want, you can go. But start the numbering from here. Why? Because, my dear friends, double bond is present and want lowest number in the IUPAC nomenclature in parent hydrocarbon. So, 6 carbon atom means hexene. Hexene is present. You can here hexene, here heptene means V is wrong answer, hexene and hexene. And hexene is present in is number 1 carbon atom. So, this is also wrong. Maybe A or D are the answers. My dear students, here you can see the 1, 2 and 3. On third carbon atom, these 3 carbon atoms are attached. So, you can see here 3 propyl. Here you can see, my dear students, these 2 carbon atoms are present. So, you can see here 4 ethyl. Answer of 15 question is that you can see here 4 ethyl, 3 propyl, hexene, hexvanine. This is the answer, and this question is asked in, my dear students, NEET 2011.